fiction films and Cold War wars, they had another poor education. The first manned Earth satellite, Sputnik 1, was launched in 1957, a scientific curiosity. Today, over 4,000 of these electronic robots encircle our planet. Our lives are extremely dependent on them, yet we rarely give them thought. Looking nothing like this, we have made the most daring explorations of the most exotic objects. We even tasted and clawed the surface of far-flung planets. Using sensor systems far beyond human, they've explored the world's hidden beneath dense, poisonous atmospheres. And some, traveling for decades through the dangerous radiation zones of interplanetary space, have revealed to us the secrets of the most distant worlds in our solar system. Robots have boldly gone where humans don't dare to go. In the late 1970s, an exceptional lineup of the outer planets allowed the two Voyager spacecraft the opportunity to quickly reach the outer solar system. Often, it was the smaller worlds orbiting the outer giants of the solar shell, like here on Miranda, a 480-kilometer moon of Uranus. This great wall is a huge 5-kilometer high cliff formed when a large block of terrain was raised high above the surface and apparently frozen into place. For a tiny world, this is gigantic. Scaled to Earth size, this would be a cliff 470 kilometers high. Out here, light from the sun, 3 billion kilometers away, is so feeble that solar panels wouldn't work. So each Voyager had to carry a small nuclear generator to provide electricity for the probe's instruments. It's the stumpy cylinder to the right of the dish-shaped antenna. The long truss carried the magnetometer, which needed to be kept distant from the craft's electronics. A movable array of cameras and other sensors were the eyes and ears of this giant robot. Boosted by its encounters with the other planets, Voyager 2's flight time to Neptune was cut from 30 to a mere 12 years. Four and a half billion kilometers from the Sun, it swept low over the outermost planet Neptune in August 1989 and into the record books. It had visited 4 planets, 2 for the first time, and explored 48 moons. It will be another 150 years before the planets align so healthily again. Oddly, the 2 innermost planets, Mercury and Venus, have proven quite difficult to explore. Mercury was partially imaged by one spacecraft in 1974 and 1975, but it would be another 33 years before a robot explorer returned. This is Messenger. After a couple of swing-bys, it entered Mercury orbit in 2011. Surprisingly, this tiny iron-core planet turns out to have a surface composition that differs quite substantially from that of Earth, Moon, or Mars. Messenger is also collecting data on unusual compounds discovered near the North Pole. Some researchers believe this could actually be water ice, but there's not enough evidence yet. Ice of any kind is most unlikely to be found here on Venus, where the surface temperature is hot enough to melt lead. Only a few Soviet Venera craft, built like tanks, have managed to survive a descent and soft landing on Venus. Their images enabled us to create this detailed surface picture of the volcanic rocky terrain. It lies beneath a carbon dioxide atmosphere 90 times as dense as that on Earth. Here, an unprotected human would be poisoned, fried, and squashed. A rather unpleasant welcome. Our knowledge of the planet's surface has been gained through the radar eyes of various orbiting craft, including one Magellan, built from leftover parts from the Voyager, Galileo, and Mariner 9 missions. This is a scientifically accurate recreation of its surface, dominated and constantly changed by intense volcanic activity. In size, Venus is almost the twin of the Earth, but its dense carbon dioxide atmosphere, sulfuric acid clouds, and furnace-like temperatures mean that this, our closest neighbor, will be one of the last to be visited by humans or even robots in the foreseeable future. The only place beyond Earth that both humans and robots have explored is the Moon. However, for many born after the 1970s, the manned moon flights are distant historical events. With the recent discovery that vast deposits of water ice may be present at the Moon's poles, the possibility of future exploration and even industrialization is more likely than ever before. Once the sole territory of the United States and Russia, the Moon has now been successfully visited by robot craft from Europe, and in the last few years, from the three Asian technology giants, Japan, India, and China. But the $30 million X Prize for the first non-government lunar robot lander is ensuring that return to the Moon will happen in the near future. The Chinese have also expressed interest in a manned landing, possibly in the next decade. United States plans for a return to the Moon have been canceled. Instead, NASA is planning a manned landing on an asteroid. The Japanese spacecraft Hayabusa captured some microscopic samples of an asteroid and returned them to Earth in 2010. Beginning in mid-2011, the Dawn spacecraft orbited Vesta, the second largest of the asteroids found between Mars and Jupiter. Its results show that Vesta has remained virtually unchanged since its formation 4 billion years ago. Yet the varieties of features suggest that this tiny world has more in common with the larger planets than previously thought. Dawn is now en route to the largest asteroid, Ceres. Someday, mining asteroids could become an important source of minerals scarce on Earth. It has been estimated that the commercial value of a typical asteroid just a few kilometers across is around $80 trillion. That's enough to pay off the U.S. national debt 5 times over. Related to, but different from most asteroids, are comets. They are more volatile and release great amounts of gas and dust as they are warmed by the sun. The most well-known is Comet Halley, whose relatively short orbit brings it close to the Sun every 76 years. So for its first return of the space age, Russia, Japan, and Europe sent robots to meet it. The most daring was the European g-৮ craft. In March 1986, it got within 600 kilometers of the comet's nucleus. During this time, the 15-kilometer-wide comet was ejecting 3 tons of material each second from 3 major vents, mostly water and carbon monoxide. g-৮ endured over 12,000 impacts from cometary debris until one violent impact knocked the craft off course and destroyed its camera. Since that time, a number of spacecraft have made more cautious approaches to less active comets. They have managed to collect some comet dust and even deliberately crash into a comet to release materials. The most difficult and dangerous comet mission since g-৮ has been underway since 2004. In March of that year, the European Space Agency launched the Rosetta spacecraft, which will rendezvous with its cometary target in 2014. Excitingly, Rosetta carries a smaller robot explorer, Philae, which is due to actually land on the comet's nucleus in November of 2014.
Chandrayaan 3 2023.
Explorations of asteroids and comets with their apparently ancient composition will hopefully tell us more about how the planets were formed over 4 billion years ago. More robots have been destroyed trying to explore Mars than any other planet. The Russians have been particularly unlucky. In 2011, their most sophisticated Mars robot got no further than Earth orbit. It had been designed to land on the surface of the Martian moon Phobos, a possible site for an early manned mission.